As a harder example of an inverse hyperbolic integral, we have this problem. I look at this and my first inclination would be a u substitution, but if we let u be the denominator, there's no du present. Okay. So instead, I'm going to complete the square on the denominator to try and get it into a nice format. Okay. So this becomes x minus 3 squared, and then I had to add and subtract 9 to get that. Okay. I did, of course, complete the square on the negative version of the denominator since it was easier. So I must switch the signs again. It becomes 9 minus x minus 3 squared dx. As is usually the case, I really would prefer this number to be a 1 to simplify my use of the formula. So I'm going to factor out the 1/9, and I need to therefore factor a 9 out of both of these pieces. All right, so now I'm going to do a u substitution with u equals x minus 3 over 3. So du is 1/3 dx. Okay. Now I have a 1/9 dx, so if I take 1/3 of it, I'm going to be left with a simple 1/3, and then 1 minus u squared du. Okay. Now, I can go to my inverse hyperbolic formula, which first of all puts a 1/2 in front, and of course the 1/3 is already coming along for the ride, and then ln of 1 plus u over 1 minus u plus c. I should be proper and put the absolute values. Now, this becomes 1/6 ln the absolute value of, well, 1 plus u is 1 plus x minus 3 over 3, and 1 minus x minus 3 over 3 plus c. You can, of course, clean this up a little bit by multiplying top and bottom of this fraction by 3. Okay, so you get 3 plus x minus 3, or just x, and 3 minus x plus 3, or 6 minus x, for a lovely final answer.